All right, so at this point, you guys should have had a few days or a day or two to look into a few different types of sampling methods, starting with a simple random sample and doing a cluster random sample, stratified, and you should have also kind of messed a little bit with a systematic random sample. So basically what we're going to do here is you hopefully gleaned a little bit of what we're going to talk about from the activity, but just to kind of make sure we're all on the same page, we're going to just kind of write down a couple facts about each type of sample. So to begin, we're going to talk about a simple random sample, which we do call an SRS. That is very common. If you see SRS, that's what it means. So our main advantage of an SRS over every other type is since I'm numbering every member of the population, every member of the population has an equal chance of being picked for the sample. No other sample is going to guarantee that. In a cluster sample, not everybody has an equal chance of being picked because it's based on location. Depending on your location, you might not get picked. Stratified random sample, not everybody has an equal chance of getting picked. It just depends on what your groups are. So for an SRS, our main advantage is every member of the population has an equal chance of being picked for the sample. And then as you may have experienced, your disadvantages kind of make sense too in just a practical way. You have to number every member of the population for an SRS, and that can be really tedious or really impossible. So our disadvantages is an SRS can actually be really tedious, meaning long, boring, annoying, or it could potentially be even impossible if you can't number the entire population. So your disadvantages are it is tedious or impossible to number the whole population. Also, because of, so that's sort of disadvantage number one. Disadvantage number two is in theory, now it is unlikely, but it is in theory possible to still randomly select a sample that's not representative, since you can literally get every combination of members. So let me write that down, then I'll give you a quick example of what I mean. So still possible, though unlikely, to randomly select a sample that is not representative. So here's sort of an example of what that would actually look like. So let's say I'm taking a sample of, I want to know all Californians. I'm interested in what all Californians think. And let's say that I could number Californians from 1 to whatever million and take a simple random sample. It could certainly be possible that my simple random sample, let's say I'm taking a sample of 1,000 people. It is certainly possible for my sample of 1,000 people to all be from the same city. Now, is it likely that if I take a random sample of all of California, every single person in my sample is from the same city? It's not likely, but it certainly is possible. And in no other type of sample would that be possible, because in a cluster random sample, you would separate California by location. And so you would pick a few different locations to make sure you have every location or a few locations covered. In a stratified random sample, you would split the state into probably location again, but maybe pull a little bit from each location. So for a cluster and a stratified random sample, you're very unlikely to get your entire sample from the same city. But in a simple random sample, So we'll just put, for example, you could get a sample from the same city. So let's say we're taking a sample of 1,000 people in California. All 1,000 could be from, they could be from LA. And then that's not representative of the whole state. So that's a huge disadvantage to a simple random sample. Okay. So we move on now to cluster random samples. Okay. So cluster random sample, and then next to each of these you have the explanation, but as you sort of saw, you take a population that's naturally separated or could be naturally separated by location, and then you number the locations and select one or more clusters and take all members from those clusters. So for example, at Edison High School, I could split up Edison High School by classroom, and I could maybe take a random sample of 5 different classrooms, and then I would sample all of the students in those classrooms. That would be an example of a cluster random sample. So huge advantage is that you don't have to number the entire population. Oops. Entire population. Not only that, but because your sample is separated by location, your sample is actually very convenient to collect. So, and your sample is conveniently located. Together. So if I were taking a cluster random sample at Edison High School and I picked 5 different classrooms, I only have to go to those 5 different classrooms, versus if I did a simple random sample where I numbered every single kid and took a random sample of kids, I would have to visit every single kid in every single one of their classrooms. So that would be kind of annoying and tedious to do. So cluster samples are hugely, hugely convenient in that way. Disadvantages that you may have noticed. This is only a good method if the clusters are naturally representative. So here's what I mean. If I was asking a question about, let's say I was interested in whether or not Edison students are satisfied with their physical classroom environment. So do they actually like the physical class that they're in? Are the desks comfortable? Is the AC too cold? What's going on? In that case, a cluster sample would be a really bad way to take a sample, because let's say that I did take a cluster sample and I wanted to get 3 different classrooms. So I I just listed all of the different classrooms and I randomly selected 3 classrooms. So let's say I ended up with P11, our class, P20 million, whatever, one of the classes in the back, all the government and freshman classes, you know the ones. And then my last class I ended up with was like W212 or something. That would actually be a really bad sample, because the only things I would have represented were the P buildings and 1 class in the W building. So that wouldn't really give me a clear idea of if kids overall are satisfied with the classrooms, because that completely omits the science building. It completely omits the weird art building theater craziness that goes on that nobody knows exists. It completely omits our buildings. So you can get the idea that a cluster sample really only works if the clusters are naturally representative. So huge disadvantage. This is only a good method if clusters are naturally representative. And furthermore, it's a terrible method. In fact, it's really a convenient sample if they are not. So, for example, if I did a cluster sample again at a stadium, let's say, so at a basketball stadium, and I wanted to know just average income of the people in the sections that I picked. If I did a cluster sample, I might choose one section because I'm not going to a bunch of different sections. Well, if I end up with a section that's near the floor, that's near the court, and I ask all of those people what their incomes are, they're going to be crazy high because you had to pay a lot of money to get those tickets. So income, trying to figure out income from a stadium, that is not appropriate from a cluster sample. Versus if I wanted to get people's opinions on flavors of ice cream, the flavors of ice cream should have nothing to do with where you're sitting. Everybody just has different tastes and flavors of ice cream that they like. So if I had chosen the same group of floor seats or near the floor and asked those people their favorite ice cream flavors, that would be totally fine. A cluster sample in that case would be totally appropriate. So hopefully that makes sense. If not, we're going to look at a few examples in just a second. And then finally, we have the stratified sample. The stratified sample is a really great sample because we're splitting the entire population up into groups, and then we're picking people for the sample or things from the sample from each group. So we are guaranteeing that every single one of our groups are going to be represented. And that is awesome. That's a huge advantage. So all strata, that's our groups, are guaranteed to be represented. In this method. In no other method are you guaranteeing that every group is going to be represented. Now, of course, it depends on how you split up your groups, but if you split them up pretty detailedly, if you will, then you are going to get a very representative sample. Disadvantages, it might be kind of difficult to separate the population based on strata, and still kind of tedious to number each of the people or things in that strata. So it might be difficult to separate the population into strata, and it's still tedious to number all members of each strata, which you would have to do. It can also be a little awkward, so let me give you an example. One of my groups who did their stats project from last year wanted to know if there was an association between race and belief in conspiracy theories. And they wanted to take a stratified random sample. That was the original goal. But then they realized it might be awkward to separate their sample based on race, because how do you do that? Do you walk into a classroom and be like, okay, hey, white people, come hang out with us for a second. We need to ask you a question. Well, that's a little awkward, right? So again, for a stratified random sample, sometimes it's a little difficult or awkward or weird anyway to separate a population into strata. So kind of keep that in mind as far as a practicality is concerned. But if you can do a stratified random sample, it is great because you can guarantee that your groups will be represented. Okay? So that's sort of a picture of advantages and disadvantages, which hopefully you kind of came to these conclusions yourself a little bit. Our last type of sample is a systematic random sample, and actually it's not technically covered by the AP exam, but it's a very common, extremely common method for taking a sample because it's really easy to do. So it would look like if I were wanting to take a sample of kids in your classroom, I would maybe line you up and I would count every fourth person, and that person would be a part of my sample. So that's sort of how a systematic sample works. You number the entire population, you choose a number at random, so 12, let's say, and you take every 12th person in your population to be part of your sample. So in real life, and actually when you guys do your project, that's a great way to take a sample. You could totally do that. It's super convenient. Okay. So now let's get into when to use which type of sample method. So it says in each scenario, actually this is the group that tried to do the race based on that's right, they also did party affiliation because they switched their ideas. They did conspiracy theories too, but anyway. So in each scenario, describe how the researchers might take a sample using one of the methods above. Explain why the method you choose would work for their particular case. So what I'd like you to do, I'll read the problems to you. I want you to pause the video and try to decide which type of sample would be best for that situation, and then why. I have explanations that I've written, so I will write those down. You can check your answers with mine, and as long as they're pretty much getting to the same conclusion, you're probably fine. So, number 1, Iffy, Sylvia, Melanie, and Lolly are planning on doing an AP Stats project trying to determine if there is an association between race and political party affiliation. They would like to collect a sample of Edison High School seniors and find out each person's identified race and which political party, if any, they identify with. Okay, so pause the video right now and try to come up with which type of sample would be best in this situation. In the meantime, I am going to write an answer. Okay, so here's sort of my idea. Your idea may match mine, it may not, and we'll talk about why I chose what I chose and what ideas you could have come up with that were good or bad. So, in this case, we want to make sure that many races and political parties are represented. We don't just want one race or one political party, because we want to see if there isn't a connection between political party and race. So here's what I'm thinking. What they originally thought was, let's do a stratified random sample to make sure that we get people from each race. And as we kind of talked about previously, that actually became a little bit awkward for them. And so that sort of didn't really work out as smoothly as they thought. So here's my thinking. My thinking is Edison High School is actually a pretty diverse place. And so I'm thinking senior English classrooms probably are going to be pretty diverse because almost all of you are stinking in AP Lit, whether you wanted to be or not. And if you seniors are not in AP Lit, then you're in Bible Lit or you're in like a handful of other classes, but really, really the vast majority of you are in AP Lit, whether or not you're an AP Kid. So there we go. So either way, I'm guessing English classrooms tend to be pretty diverse racially and politically. So what I'm thinking is, let's take a cluster sample of all senior English classes. So we would number all the English classes and randomly select 3 of them for a sample and ask each person in the class to fill out a questionnaire identifying their race and political party affiliation. This way, you're sort of guaranteeing, not really guaranteeing actually, but this way you're going to most likely come up with a sample that's pretty diverse. We're not just looking at one English classroom, we're looking at a few. And that should get me a pretty decent sample. Now, that's my recommendation. Is it perfect? No, because I can't guarantee that I'm going to get every race and political party affiliation represented. But it's going to be pretty good. And pretty good for AP Statistics, friends, is good enough. So I would recommend in this situation taking a cluster sample because the clusters, in this case English classes, are going to probably be naturally representative. Okay? So that's sort of my idea. If you said stratified, I totally understand that because you want to make sure you have every race represented. And if you were actually explaining this in an AP test, you wouldn't be wrong. They would probably give you full credit as long as you backed up what you were trying to say. Simple random sample in this case would be okay, but as far as practicality goes, what a nightmare. So kind of keep that in mind. So I would say first one, cluster random sample. So let's look at our second one. And then same thing, pause it, come up with an idea, and then we'll check with the last one. So it says a large apartment building is planning on renovating their floors and painting their walls. They could do renovations anytime within the next few years, and the management wants to get an idea of the condition of each apartment. This particular apartment building does allow pets, has many families with small children, and a few residents who smoke regularly. Also, there are some families who have no pets, no small children, and don't smoke. The management would like to take a sample of apartments to check the conditions of each. Okay. So in this case, I want to know what kind of sample would you take. So come up with a type of sample, how you might take it, and why you would take it. Okay, so pause the video. I will write an explanation. You can judge me afterwards, and we will move on. Okay, so here's my recommendation. And in this case, in number one, you really could have gone a couple of different ways with different samples. For number two, you really can't. So in this case, we need to make sure each type of apartment is represented, since smoking, pets, and small children would likely damage an apartment much faster than none of those things. So because of that, we need to make sure every type of apartment is represented. And the only sample that guarantees each type of apartment would be represented is a stratified sample. So in this case, we would use a stratified random sample. And the way we would do it is we would separate the apartments into those with pets, those with children, smokers, or none of these. Then we would randomly select a sample from each group and check their apartments so that we could see for each group how are their apartments doing. And then I added this detail in for funsies. You might have dealt with this differently, but I said for apartments with multiple of these factors, like both small children and pets, you would just place them in one of the two strata. So for example, if I found an apartment that had 3 dogs and a 2-month-old baby, the 3 dogs would be a bigger deal than the 2-month-old baby, so I would put them in the pets category. So for this one, for number 2, you kind of don't have a choice. You need to go with stratified. You need to mention in this case that you're going to guarantee each type of apartment is represented. And the reason why you're doing that is what we said here, which is because any of these things, small children, pets, etc., are way more likely to damage an apartment faster. So we would need to know what all of the apartments look like. Basically, what we don't want to happen is we don't want to end up choosing a random sample, in this case, that's just people with none of these things. So if I ended up with 5 apartments and all 5 of them, none of them had pets, none of them had kids, none of them smoke, I might think, hey, these apartments are in great shape, when in reality, the other smoking children pet apartments are in terrible shape. So in this case, a stratified random sample is pretty much the only way to go. All right, last one. So here we go. Alex is doing a study for his AP Stats project on whether or not teachers at Edison are happy with their current positions. He has a list of all 106 teachers and does not have time to interview all of them, so he plans to take a sample. Okay, so practicality speaking, however you want to do this, but come up with a sampling method for this situation and then check with me in just a minute. Okay. So this is sort of my defense, and I wrote a lot. You might not have written as much as I did. That's okay. So practically speaking, since he already has a pretty short list of all teachers, and yeah, 106 is, but it's pretty short, all things considered. He should really just do an SRS. He should do a simple random sample. He already has 106 teachers. He could just number them and choose, I don't know, 20 at random, 10 at random, however many he wants. The reason why a simple random sample in this case is probably fine is because he just wants to know if teachers in general are satisfied with their jobs. He's not wondering if there's an association between the subject you teach and whether you're satisfied with your job. If he was, then he would want to make sure that he had every subject represented. And in that case, a simple random sample would not be a good idea. But in this case, he just wants to know whether or not teachers are happy with their current position. So that's pretty general. There's not really any need to take a stratified sample. Also, if he did take a cluster sample, if he did it based on location, in this case, teachers are grouped on campus based on what they teach. So in general, most of the math teachers are all together, most of the English teachers are all together, etc. Most of them. So it could happen if he took a cluster sample and he split up all of the campus by building. So P's would all be one building, for example, science, W. If he did that and then he sampled the whole building, let's say he ends up with the science building. Well, then he's only focusing on science teachers, and maybe science teachers aren't representative of every teacher. Maybe they all hate everything and they hate their jobs and they're miserable. Or maybe they're happy as little clams. But either way, if he took a cluster sample, he might get a non-representative sample. And a stratified sample is cool and all, but there's really no need to do that because he doesn't care about if there's a connection between subject matter and satisfaction. He just wants to know if they're satisfied. Not only that, but he's got a complete list of all teachers, and the list is pretty short. So I would say here he should do a simple random sample. So if you said simple random sample, great, I agree with you. Practically speaking, really the first sentence is kind of all you need. But you might be asked on an AP test, hey, what type of sample should he do? What type of sample should he not do? And in that case, you would have to kind of explain what I explained, which is stratified is kind of overkill. You don't need that. And a cluster sample could actually screw you over in this case because it could be non-representative. All right. So this is kind of a good picture of what your homework is like. This is a good picture of what you're going to be asked to do on a homework quiz. And if you haven't noticed a little bit, these are kind of subjective. So if you back up what you're saying with a logical explanation, you're probably going to be fine. But be careful because the correct answer to number 2, for example, was stratified. There was really no other option. And for number 3, the only wrong answer is a cluster sample. You absolutely, in this case, should not do a cluster sample. So kind of be aware of that. When you're choosing a sample, make sure that it actually fits the situation and make sure you can back up how it would fit the situation. As long as you're good with that, you are good to go. All right, y'all, have a lovely day.